For 200 years, the island of Krakatoa sat in the middle of the Sunda Strait and did nothing. The Sunda Strait is the narrow channel of water that separates the islands of Java and Sumatra in the Dutch East Indies. At its narrowest point, it measures roughly 26 kilometers across. Krakatoa sat near the center of it, visible from both coasts on a clear day, a cluster of 3 volcanic peaks rising from the ocean floor. Sailors knew it as a landmark. The Dutch colonial charts marked it. Fishing boats from Java and Sumatra passed near its shores. The island had last erupted in 1680, more than 2 centuries before, and in the years since it had settled into the kind of stillness that coastal populations learned to read as permanence. By 1883, the towns along the Java side of the Sunda Strait had grown into something that resembled permanence themselves. Anjer, the main port on the western tip of Java, was a refueling stop for ships passing between the Indian Ocean and the Java Sea. Its lighthouse was one of the most important navigation aids on the route between Europe and the Far East. The town had a telegraph office, a harbor master's office, warehouses, and the kind of settled commercial life that builds up around a port with regular traffic. Merak, a few hours north, was a smaller harbor but equally established. Across the strait on the Sumatra side, the town of Teluk Betung at the head of Lampung Bay served as the administrative center for the region's southern districts. These were working communities that had been doing what they did for generations. None of them had living memory of Krakatoa as anything other than a landmark. On the 20th of May, 1883, a Sunday, the island made a sound. A German warship, the SMS Elizabeth, was passing through the Sunda Strait that morning. Its crew heard what they described as a series of detonations coming from the direction of Krakatoa, and they watched a column of white steam rise from the island to a height they estimated at 11 kilometers. By the time they were clear of the strait, ash was falling on the ship's deck. The captain logged the event and continued on course. The eruption was reported to the Dutch colonial authorities in Batavia, the administrative capital on the Java coast, roughly 160 kilometers to the east. The colonial government sent a team to investigate. The report that came back described an active vent on Perbawatan, the northernmost of Krakatoa's 3 volcanic peaks, with continuous ash emissions and periodic explosive activity. It also described something that would define the official response to everything that followed. The eruption appeared to be of moderate intensity, and the island's 2 other peaks, Danan and Rakata, showed no signs of activity. The assessment was cautious and accurate as far as it went. It did not go far enough. What the assessment could not account for was what was happening underground. In the weeks after the May eruption, Krakatoa became something of an attraction. The Dutch authorities in Batavia organized an excursion to the island in late May, with a party of around 100 people, including government officials, scientists, and journalists. They landed, walked across the island, took samples, made observations, and returned to Batavia with accounts of a moderately active volcano that was interesting rather than alarming. The excursion was reported in the colonial press. Subsequent ships passing through the Sunda Strait noted the eruptions and logged them, and the logs became less alarmed as the weeks went on and nothing catastrophic happened. By June and July, the volcanic activity at Krakatoa had become a fixture in the regional consciousness in the way that any visible, sustained, non-lethal phenomenon eventually does. Something that was always there, present enough to be noticed, steady enough to be ignored. The coastal towns continued doing what they did. Ships continued to refuel at Anjer. Fishing boats worked the strait. The lighthouse at Anjer continued to warn ships away from the rocks it had always warned them away from. If anyone in the region's administrative structure drew a formal connection between the sustained volcanic activity on a 200-year dormant island and any risk to the coastal populations on either side of the strait, that connection was not reflected in any action taken. By August, the activity on Krakatoa had intensified. Ships passing through the strait reported that the ash columns were higher, the sounds louder, and the ash falls denser than in the earlier months. The strait itself was navigable but uncomfortable. The pumice floating on the water's surface had thickened in places to the point where ships had to push through it. The water temperature in parts of the strait had risen measurably. These were not subtle signs. They were logged by trained mariners on professional instruments, and those logs reached port offices and harbor masters' records in Anjer and Batavia. The information existed. The action it prompted did not. On the afternoon of August 26, 1883, the eruptions on Krakatoa moved into a different register. At around 1 in the afternoon, an explosion of significantly greater force than anything the preceding months had produced sent an ash column rising to an estimated height of 27 kilometers. The sound was heard across both sides of the strait. The ashfall that followed was heavy enough to darken the sky along the Java coast for the rest of the afternoon and into the evening. Ships in the strait reported ash so thick it made breathing difficult on deck. In the towns along the coast, people shut their windows and waited. This was not the familiar background activity of the previous months. This was something louder, and the people on both sides of the water knew the difference. Through the night of August 26th, the eruptions continued without stopping. The crews of ships in the strait described a continuous sequence of explosions, each one generating a pressure wave that could be felt in the chest, with lightning playing constantly in the ash column above the island. The sounds carried for hundreds of kilometers in all directions. In Batavia, people were woken by the concussions at distances that would ordinarily have placed them well beyond the range of any volcano they knew. In the towns along the strait, no one slept. The morning of August 27th arrived. At 5:30 in the morning, a large explosion sent a fresh column of ash and rock into the air, larger than the previous days. The tsunamis it generated were small but real, noticed on the coast as unusual swells. At 6:44, another explosion, larger still. The waves generated by this one reached the coastal towns, and the water was noticeably higher than it should have been for a few minutes before receding. At 10 minutes past 10 in the morning, Krakatoa exploded. The event lasted approximately 3.5 hours from the initial detonation to the point at which the main caldera collapse was complete. But the defining moment, the explosion that produced everything that followed, occurred in the first minutes. The sound it produced was unlike anything any living person had heard. It was not a rumble or a roar. Every account from people within 100 kilometers of the strait describes a pressure impact, a physical force, something that arrived as a blow rather than a sound. Windows across Java and Sumatra that had survived the explosions of August 26th shattered simultaneously. The shockwave blew the doors of buildings off their frames. Horses and cattle bolted. People were knocked off their feet not by shaking ground, but by the air itself. The ash column that rose from Krakatoa in the minutes after the explosion was later estimated at more than 80 kilometers in height. The clouds spread across the sky at a speed that darkened the region around the strait to complete blackness within the hour. Batavia, 160 kilometers away, lost the sun. Lamps had to be lit at midday. In Bandung, 250 kilometers from the strait, the darkness was total enough that cattle in the fields lay down and birds returned to their roosts. The wave generated by the explosion and the caldera collapse that followed moved outward from Krakatoa in all directions. The coastal towns it was moving toward had been in existence long enough that their inhabitants understood them as permanent things. Anjer had a population of several thousand. Its market served the villages of the interior as well as the port itself. The children of the harbor pilots and the customs officers had been born in the town, as had some of their parents. The lighthouse keeper's log at Anjer recorded the comings and goings of ships in handwriting that had accumulated over years into a record of continuity. The town's elevation above the harbor was not significant. Almost nothing in Anjer was more than a few meters above the sea. That had never mattered, because the sea, in the memory of everyone living there, had never done what it was about to do. On the Java coast, Anjer had been functioning through the morning under the conditions of the previous night. Ash still falling, sky dark, the distant concussions audible. The harbor master's office was operational, the telegraph was working, the lighthouse was staffed. There was no instruction from Batavia to evacuate. The intensity of the ashfall and the sounds from the strait had not produced an official response from the colonial administration that reached the coastal towns in the form of an order to move to higher ground. What the colonial administration was doing in the hours between the escalation of the eruptions on the afternoon of August 26th and the destruction of the coastline on the morning of August 27th is not fully documented because the offices that might have produced those documents were themselves destroyed. The first wave reached Anjer at approximately 10 in the morning. The accounts that survived came from people who were either at elevation when the wave arrived or who found elevation in the seconds available to them after they saw the water moving. What they described was not a wave in the sense that a coastal person understood waves. The water did not arrive as a crest. It arrived as a rising, a rapid and continuous elevation of the sea surface across the entire visible width of the bay, as if the ocean floor were being pushed upward from below. Then the front of it hit. The town of Anjer was gone in minutes. The lighthouse, which had stood as a permanent landmark for decades, was taken by the water. The harbor buildings, the warehouses, the telegraph office, the harbor master's offices, the residential quarters where the town's Dutch administrators and their families lived. The water moved through all of it and continued inland. The surge's height at the Anjer shoreline was later estimated at approximately 15 meters. The town's population at the time numbered in the thousands. The number who survived was recorded afterward in Dutch records as a small fraction of that. Among those who survived at Anjer were people who had been at some elevation inland when the water arrived, or who had managed to climb to rooftops in the seconds between seeing the bay behavior change and the main surge reaching them. Their accounts, collected in the weeks afterward by Dutch administrative officials, described the sequence consistently. First, the bay emptying, the water pulling back and exposing the harbor floor and the rocks that were normally submerged. Several witnesses described seeing fish stranded on the exposed bottom. Then the front of the incoming water appeared. The interval between the water pulling back and the surge arriving varied in the accounts from a few seconds to perhaps 2 minutes, depending on the position of the witness. It was not enough time for most people to reach any elevation that made a difference. Merak, to the north, was struck by a wall of water that multiple accounts placed even higher than what hit Anjer. The town was more exposed, positioned at a point where the topography of the bay concentrated rather than dispersed the incoming energy. Nothing remained of Merak afterward. The Dutch administration's assessment of the damage there occupied a single paragraph in the subsequent official report because there was almost nothing left to assess. The surge crossed the strait. On the Sumatra side, the town of Teluk Betung at the head of Lampung Bay was struck by a succession of waves that arrived over the course of the morning. Lampung Bay concentrates incoming swells in the same way that a funnel concentrates liquid, and the waves that entered it from the Sunda Strait arrived amplified rather than reduced. The government buildings of Teluk Betung, the customs house, the harbor facilities, the residential neighborhoods closest to the water, all of it was struck. The waves reached far enough inland that debris from the town was found in the hills above the valley floor. A small government steamship called the Baru was moored in Teluk Betung's harbor that morning. The wave lifted it off the harbor bottom, carried it through the town, and deposited it approximately 3 kilometers inland in a valley above the original harbor site. The ship was found afterward resting on its keel in a position far above the water that had carried it there. The entire crew was dead. The water also moved outward from the strait into the Indian Ocean to the west and the Java Sea to the east. Coastal communities that had no view of Krakatoa, that had not heard the morning's explosions clearly, that were going about their business with no particular awareness of what was happening 100 kilometers away, were struck by water arriving without announcement. The surge reached the western coast of Java. It reached the southern tip of Sumatra. It traveled through the Java Sea fast enough to reach Batavia's coastal districts before the morning was over. The captain of a Dutch merchant vessel anchored off the Java coast south of Anjer recorded in his log that the water in his anchorage rose and fell 3 times over the course of the morning, each rise large enough to strain the anchor chains. He had heard the explosions from the direction of the strait and had concluded that he was at a safe distance. He survived, and his log survived with him. It is one of the records that documents how far the motion in the water extended from its point of origin. Among the ships in the strait when the main explosion occurred was the Governor-General Loudon, a Dutch colonial passenger vessel. The Loudon was positioned close enough to Krakatoa that its captain, T.H. Lindemann, and his crew witnessed the eruption from a distance of approximately 15 kilometers. Lindemann's account, filed afterward with the Dutch maritime authorities, described the explosion as producing a wall of fire, followed immediately by a wave of air that struck the ship with enough force to damage the rigging and knock crew members from their feet. The volcanic cloud rose so fast that within minutes of the explosion, the ship was in complete darkness, navigating by compass with no visible reference points. Lindemann brought the Loudon through the strait without losing the ship. His crew survived. Lindemann's log of the morning of August 27, 1983, is one of the primary first-hand accounts of what happened in the Sunda Strait that day. The pyroclastic flows that Krakatoa produced in the hours of the eruption did not travel only downward into the water. Some of them traveled outward across the surface of the strait itself, pushed along by the energy of the explosion and the pressure differential between the dense pyroclastic material and the air above the water. The Java coast on the opposite side of the strait showed evidence afterward of pyroclastic material that had made the crossing. The coastal areas of Java closest to the strait recorded deaths from burns in addition to drowning, people who survived the first wave but were then reached by the hot material traveling across the water. By early afternoon on August 27th, the main activity on Krakatoa had subsided. What remained of the island was dramatically reduced from what had existed before. The northern portion of the island, where Perbawatan and Danan had stood, was gone. Where the peaks had been, there was now a submarine caldera, a depression in the ocean floor several kilometers across and hundreds of meters deep, the space from which the material of the explosion had been expelled and into which the remaining structure had collapsed. The island of Krakatoa, the southern peak, survived as a partial remnant, its northern face sheared away to reveal a cross-section of its volcanic interior, a cliff face of layered rock dropping straight into the water. The eruption was over. The reckoning was not. In Batavia, the first reports began to reach the colonial administration through the afternoon. They were incomplete because the telegraph lines that would have carried detailed information from the coastal stations were, in most cases, no longer operational. The lines from Anjer had gone silent. The lines from Merak had gone silent. The lines from the stations along the Sunda Strait had gone silent in sequence, each one cutting off at approximately the time the wave would have reached it, though no one in Batavia understood that pattern until later. The reports that did arrive came from places that were damaged but not destroyed, from officials who had survived and reached working telegraph equipment by whatever means were available to them. The colonial administration in Batavia dispatched ships to the strait. What they found when they arrived took days to comprehend in its full extent. The coastline of the western tip of Java had been rearranged. Anjer did not exist. Merak did not exist. The village of Sirik, which had been north of Merak, did not exist. Smaller fishing communities along the coast, which had not been prominent enough to appear in the official reports of the preceding months, had simply ceased to be. The land surface in the lowest coastal areas had been stripped of everything that had been built or grown on it. The harbor that ships had been calling at for decades was unrecognizable in its underwater topography because the wave had moved the bottom material. The official Dutch colonial casualty count, compiled over the months that followed by the administration's surveyors working through what remained of the coastal districts, arrived at a figure of 36,417 dead. The number represented the confirmed identifiable deaths the administration's record-keeping apparatus was capable of documenting. It did not include the fishing communities whose census records had been destroyed along with their settlements, the vessel crews whose ships were never found, or the people from inland communities who had come to the coast that morning for reasons that now could not be determined. The true total was understood at the time to be higher than the recorded figure. By how much, the surviving official structure had no reliable method of determining. The ash cloud that the explosion had sent into the upper atmosphere did not stay over the Sunda Strait. In the weeks following the eruption, the finest particles of volcanic material, suspended at altitudes above 25 kilometers, began their global circulation. The trade winds and the atmospheric circulation patterns that distribute material at stratospheric altitude carried Krakatoa's ejecta eastward across the Pacific, northward and southward from the equatorial band, and eventually around the entirety of the planet. The process took months to complete, but its effects were noticed within weeks. In September and October of 1883, observers across the tropics began reporting unusual coloration in the western sky at sunset. The phenomenon was not subtle. The sunsets were not merely vivid. They were red in a way that had no precedent in the experience of the people watching them. Reports of the unusual skies came from Colombo, from Calcutta, from Singapore, from Manila. They came from ships at sea in the Pacific. They came from observations recorded by weather stations at distances so far from the Sunda Strait that the connection to the eruption was not immediately obvious. The sound of the August 27th explosion had reached distances that were reported and then disputed and then confirmed. The island of Rodriguez near Mauritius received the sound at a distance of approximately 4,800 kilometers from the Sunda Strait. Observers there described hearing what seemed to be the report of distant heavy guns, sustained over several hours. They logged the observation, contacted the colonial authorities, and asked what ships might be in distress in the Indian Ocean. They received no satisfactory answer because the answer, that they were hearing a volcano exploding on the other side of the ocean, was not a category of explanation available to them in August of 1883. In Australia, at stations on the western coast, similar reports were filed. The sounds traveled to Sri Lanka, to the southern tip of India, to Diego Garcia. The total documented radius within which the explosion was heard by reliable observers was the largest ever recorded for any single event in the Earth's atmosphere up to that point. The barometric instruments at weather stations around the world registered pressure waves from the August 27th explosion for several days after the event itself. The waves circled the planet, measurable on recording instruments, and then circled again. The mechanism by which an explosion could produce pressure waves that traveled the circumference of the Earth was not fully explained by the scientific understanding of 1883. That the waves existed was documented in instrument records on 5 continents. By November, the unusual sunsets had reached Europe and the Americas. In London, in Paris, in New York, people who had read about the Krakatoa eruption in their newspapers and understood it as a distant colonial catastrophe now watched the same sky that had been turning colors over Asia for 2 months. The red was sometimes deep enough that people in London called fire brigades, mistaking the illuminated horizon for a conflagration somewhere in the city. Letters to newspapers reported the colors, asked for explanations, compared observations from different locations. The astronomical and meteorological societies of Europe began collecting the observations systematically, understanding that something was distributing material globally in the upper atmosphere at a scale that had not been documented before. The coloration lasted into 1884 and faded only gradually through 1885 as the stratospheric particles settled and were removed from the upper atmosphere. During the period of peak concentration, the global average temperature was measurably lower than in the years preceding the eruption, an effect recorded in thermometer readings at weather stations around the world. Harvests in the Northern Hemisphere in 1884 reflected growing conditions that were slightly cooler and cloudier than the seasonal averages of recent years. None of this was understood in its mechanism at the time in the way it would later be understood, because the scientific apparatus for connecting a volcanic eruption in the tropics to a temperature anomaly in the global record did not yet exist as a systematic discipline. What existed were observations, the sunset colors, the temperature readings, the reports from ships and stations around the world of something unusual in the upper air. The Dutch geologist Roger Verbeek, who led the official scientific investigation of the eruption on behalf of the colonial government, compiled these observations into a report published in 1885 that documented the global reach of the event's effects. Verbeek had no category for what he was describing. He described it anyway, in the precise and detailed language of the field observer, without a theoretical framework that could have explained the mechanism to his contemporaries. The report stands in the scientific literature as one of the most complete documentations of a volcanic event in the 19th century, assembled from the wreckage of the colonial administrative apparatus that had failed to act on the information available to it before the eruption reached its conclusion. The information that had been available before August 27th was not absent from the record. It was in the ship's logs that recorded the May eruptions. It was in the excursion report that the Batavia officials compiled in late May. It was in the accounts of the ash falls and the unusual atmospheric conditions over the strait through June and July. It was in the log entries of the vessels that navigated through pumice fields and falling ash in the weeks before the main explosion. The pattern was documented in real time by trained observers whose professional responsibilities required them to record what they saw. The coastal towns that those observers' logs were protecting received no warning. The 36,417 people counted in the Dutch colonial record did not include the people in the fishing communities whose existence had never been formally recorded by the colonial apparatus. They did not include the sailors on the smaller vessels that had been in the strait that morning, whose ships were never found and whose names appeared on no manifest that survived. They did not include the people who died in the weeks following the main eruption from injuries, from the loss of shelter, from the contamination of water sources in the coastal communities that had survived partial destruction. The Dutch colonial administration rebuilt the harbor at Anjer. The lighthouse was replaced. The telegraph cables were relayed. The coastal communities that had held enough survivors to reconstitute themselves did so, on the same ground, within the same reach of any future surge that might originate in the same strait. The volcanic island that had produced the event was diminished, but not gone. The caldera that had formed in the northern section remained underwater, an irregular depression in the floor of the strait at depths that varied according to where the material had settled. The administration sent surveyors to map the new coastline because the old charts were no longer accurate. The harbor approaches had changed. The depth soundings were wrong. The rocks that the lighthouse had warned ships away from were not in exactly the positions the existing charts showed. The subterranean rearrangement of material in and around the strait had produced changes in the seafloor that required months of new survey work before the passage could be navigated with the same confidence it had been navigated before the eruption. Ships continued to use the strait throughout the survey period because the trade route it provided was too important to close. They navigated with extra caution, by the reports of the vessels that had gone before them, in the way that sailors have always navigated through waters that the charts do not yet fully describe. In 1780 and 1781, observers in the Dutch East Indies had recorded eruptions from Krakatoa. In 1680, a major eruption had sent ash over the region. The island had been active before the 2 centuries of silence that preceded 1883, and the historical record of that earlier activity existed in Dutch colonial archives that had been accumulating since the 17th century. Whether any official who received the reports from the May 1883 eruptions consulted those archives is not documented. Whether consulting them would have changed the administration's response is a question the record cannot answer, because the response was the same either way. The ash from the August 27th explosion circled the Earth and produced sunsets that people on 5 continents watched and wrote about and did not connect, for weeks, to a volcanic island in the Sunda Strait. When the connection was eventually made, through the systematic comparison of observations from stations around the world, it revealed the scale of the event in a way that the casualty counts and the damage surveys could not. The sound had traveled to the edge of what the human ear could distinguish from silence. The ash had reached heights that no balloon or instrument of the era could access. The wave had run for thousands of kilometers from its point of origin before it was too small to measure. What it had not done was arrive without warning. The warnings were in the logs. They were in the excursion report. They were in the ash that had been falling on the coastal towns for 3 months before the wave. The warnings were recorded in the language of trained observers who understood what they were looking at, and filed in the places where the colonial administration kept its records, and acted on in no way that preserved the lives of the people living within reach of what was coming. The lighthouse at Anjer was rebuilt. Ships began calling at the new harbor. The telegraph was reconnected. The colonial record, which had been interrupted by the wave and then resumed by the survivors, continued to accumulate in offices on the same coast at roughly the same elevation as the offices that the wave had taken.